In this video, we're going to take a look at the system clock again. Now, this is actually about probably the third or possibly the fourth iteration of the original system clock since the very first Design a CPU course. So remember, these courses have been made over the space of a few years. So it's not surprising that we come up with better designs. Now, the new design here has been generated by Timothy Morgan, and I'm quite pleased that he's come up with this new design. It's actually quite important, and it does get rid of one of the little blips that has existed in the system clock since really the beginning of the first course. So let's have a look and see what issue exists in the clock at the moment, and then we'll go ahead and we'll have a look at the new design. And the new design is actually quite neat, and it's quite easy to explain. So as it stands at the moment, whenever we click on the reset, then the internal clocks are in this position, these positions here. Now I'll actually change this because that should say a 1. Okay, so the initial starting position when we click on this, when we set the thing up at first, is 1, 1 and 0. Okay, now it doesn't matter for the moment if you've forgotten what these actually are. You know that this is the clock enable, this is the clock set, and this is an internal clock position. So I brought these out to the top level originally because I wanted to make sure that we always started in the correct position with the clock. So this is the correct position here. Now let's say for instance we have ran through a little piece of code, so we've clicked through and the clocks are all going to change. Okay, now if we're in a position here, we end up with say this position here. Whenever we press the reset, okay, everything resets but except the clock. Okay, so these internal clock positions don't reset. Now sometimes it doesn't really matter if they don't reset. We can still go ahead and we can load up the new code, and then we can just start running the clock again and everything runs fine. But there are certain positions that if we were to go and run a new piece of code, then we would run into problems. So let me show you one of these for example. So let's say for example we've ran through a piece of code and we're in this position. So the end of the program has come along, and when the program has ended, the clocks have all ended in this position. So the main clock input, so this is the main system clock for the whole of the CPU, is sitting in a high position, and all of these three are sitting high as well. So what we could do is we could go in and we could reset this, and then we could go in and we could load in a new piece of code into the RAM, and then we could start the clock again. And when we start the clock again, you can see that we've got a problem. Okay, so there's an issue here. Now the issue is that we're not in the correct starting position, and we end up with everything in a mess. So what we have to do in this case here is we have to finish off the simulation, okay, and then we have to reset the simulation. Everything has to be set back to the original position, and this whole thing takes time. So we might sit here for 10 or 20 seconds while this all works out. So you can see here it's going through in effect the reset for our whole circuit within Logisim. So I'll leave it for a few seconds longer, and you can see how long this can take. And the point is that this is really just a bit of a pain, and we really don't want these particular events to occur. So now we're ready to start again, and we can go reset. Okay, now we don't want that to happen. Okay, that's pretty garbage. We want rid of that. So if we head down into the clock at the moment, so this is the clock as it exists at the moment. And if we head in, the clock looks like this. Okay, now what we're going to do is we're going to go through the upgrade. So I will bring up the new RTM16 with the new clock, and we'll show you that this problem no longer occurs. Now we have the new clock added here, and I'll show you the difference from the previous setup. So let's say we click on the reset. When we click on the reset, we're in the position 000. Okay, so all of these internal clocks are sitting at 0, and then we can start clicking through. So the very first one clicks to this position here, so it's 010, and then we can start working through. Now it still passes through and it generates the clock in the correct manner, so that obviously the whole computer still works. Now let's see what happens when we finish off in the position that we've seen previously. So in the position we've seen previously, we're going to have one of the clock in is actually at a high level. Okay, so whenever we click on the reset here, it's going to reset all of the internal clocks, but the clock in here is sitting in a high position. Now we can go ahead and we can load in the code into the machine, so the new code for the next program we want to run, and then we can start running it, and there's no problems. It doesn't matter what position this clock's in and what position these are sitting in. Whenever we press the reset button, we can be sure that all of the internal clocks are in a stable position, so that whenever we load the next piece of code into the RAM, it's going to start running. Okay, so we could have simulate, tick enable. Now there's no program in, it's just running through counting up the instruction address register. But the point is, if I go in here and I stop and I press reset, I can get in and start again. And you can do that and be happy in the fact that anytime you press the reset button here, you can be absolutely sure that you can load in the new piece of code without running into any issues regarding the position of the internal clocks after you ran the last piece of code. So it's quite an important and quite a useful update. So let's drop in and we'll see the new circuit. So if we head into the computer and then into the CPU. Now the first thing to note here is that I've moved things around about just a little bit. So let's look at the original setup at this level. So that was the original setup on the right hand side and the new setup on the left. So all I've done is I've shifted the connections here for the clock and the ALU, and I've put the connections for the ALU below the connections for the clock. It was just a little bit neater. Also you can see here that the clock, the end here and this AND gate, I've now got rid of these and I've actually placed it within the new clock. It's just a little bit neater. Okay, so the new setup looks like this here, and the old setup looks like this here. I've also taken the flags here and I've shifted the flags up so that the flags at this point here, and I've shifted them up so they're in this position. It's just a little bit neater and tidier. So let's drop into the actual clock and we'll see where the differences are. So this is the new clock here, and let me just talk through how this works. So let's start off by resetting the circuit. Now what we have here on the right hand side are the output clocks, and we have the mux here. The control line for the mux is down here, and when it's a 0 it chooses this ROM output, when it's a 1 it chooses this ROM output. There's some control circuitry here which we'll see working in just a moment. Now we have 3 outputs here, so it means that we'll have 2 to the power of 3, so we'll have 8 possible combinations of these outputs. So we could have all of them off, or we could have all of them on, and a mixture of the other 6 possibilities in between. So as it stands at the moment, all of them are off. We can see that this line here is low. If it's low, it's choosing this ROM, therefore it's choosing the value of 0. So if it's choosing the value of 0, it means that none of these have gone high because everything is sitting at 0. Now if we were to click the first clock pulse through, you can see here that the ROM has jumped in both cases, and that's what this circuitry here is for. It controls the position within each of the ROMs. Now this is set up so that we can think about the bottom line as being 2 to the power of 0, and the next line is 2 to the power of 1, and the next line is 2 to the power of 2. So for example, if we wanted all 3 of these on, then we would have to have 2 to the power of 0, so that would have to be high, so that would be 1, and then it would be plus 2, plus 4, so we would have to have a value of 7 on the output to have all of these 3 on. Now if we only want this one on, then we're going to have the value of 2. And you can see here, this line is still low. We're picking this point here, and we're picking output 2. So 2 passes via here, and it chooses the clock enabled. When we click on the next clock pulse, this line still remains low, and you see we've got all 3 outputs. So we've got all 3 outputs because it's passing 7 through the mux. And then we can continue on to the next one. In the next one, you can see that only the top 2 are live, so that's going to be 2 to the power of 1 plus 2 to the power of 2. So that's going to be 2 plus 4, which is 6. So it's passing on the number 6. So when we click on the next clock pulse, you can see that this line here is still low. So it's going to pass on the next value, okay? So the next value is the 0, and that's us going back to the beginning of our cycle. So we're going to have our 4 clock pulses for our entire cycle. And we can just continue through that route. And the way it's set up just now, we start off at 0, and then we go to 2, 7, 6, 0, 2, 7, 6, and so on and so forth. So now if you're looking at that, you would be wondering, well, what is this ROM here for? So let's explain that next. Now, as we mentioned before, whenever the last program has run, The final position of the master clock could be a 0 or a 1. So in this instance we assume it's a 0, but let's assume that the master clock has a value of 1. So we would be starting off by resetting the circuit, and the master clock is sitting at a 1. So now we're going to be passing through this line here, and we're going to be passing the values through from here. So in that case here, we're going to start again with a value of 0, 0 and 0. So whenever we click through the first clock pulse, we're going to be passing out the bottom ROM, and again we're going to pass out the 2, which was the same in the top ROM. We would have been in this position, but now we're in this position. So we pass out the 2, and then the next one comes along, and we pass out the 7, and then the final one comes along, and we're going to be passing along the value of 6, and then it goes back to 0 again, and that's us finished the entire 4 clock pulses to generate our set and enables. So that means that we always get the same clock pulse signals out for each of these clocks, irrespective of whether the master clock is at a position 1 or a position 0 at the beginning of the cycle. So finally we can have a look at our clock pulses. So this is the master clock running in here. We have got our clock set, which is in effect is our 2 to the power of 0. We've got our clock enabled, which is 2 to the power of 1, and clock here, which is 2 to the power of 2. So you can see here that we have the clock here, which is running at half the frequency of the master clock. And then we generate the set value here, and you can see that the set value sits entirely within the enable. So in effect we can see we're going to have a 1, 1, 1 for our enabled, and at the same instance we're going to have a 0, 1, 0 for the set, and that continues throughout. So we've got the correct clock, set and enable values. So this is quite important, and it's quite a useful addition to the entire setup. It means that the entire CPU is a lot more stable, and we don't need to go continually resetting it via Logisim. We can just click the reset button on the actual circuit. Now, this was generated at the end of the Design a CPU 4 course, but I've actually added it in to the actual circuit that you're going to be using on the Design a CPU 4 course. So it means when you open up the actual circuit in Logisim, it will look exactly like the circuit you see here. But when you look at the videos will be slightly out of date, and you'll be looking at the videos with the previous clock circuit. But that's no matter, everything else still works exactly as it was previously. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.